the TCP protocol. Is it secure or is it insecure? In this video, I'm going to discuss the insecurities of the TCP protocol. So first of all, what is a TCP protocol and what is a protocol? I'm going to zoom up a bit here and basically draw the typical drawing you do when you learn about protocol. So you say that someone is going to send a message to someone else, and that one is going to respond back, and then they can communicate and so on. So basically a protocol is a set of rules dictating how the communication should work. So let's assume that you're a programmer. Then of course when you do your first socket programming, you can do something called a string-based protocol, which is basically whenever you do your strings like this, for example, string message equal to something, then in the start of it you can say that this is a B colon B for broadcast, so it's sent to everyone, or it could be anything. Basically, if it's a B and a colon, you look for. So when you receive this on the number 2 here, on the second client, basically that client is gonna pass it and say, okay, so I know how to interpret this message. Now, if you're just sending something directly to another person, then there is no server, and then this is basically the way it's gonna be. Now, if you're doing something called a client-server setup, then you have your server right here, server S, and then you have all your clients like this, talking directly to the server. The clients does not really know about each other, so they are isolated to their own box. So how does the client then know who's connected to the server and everything? Well, basically that is a part of what the protocol is. So when you connect to the server, depending on which channel you joined, if there's a channel called chatting or heavily chatting or less heavily chatting or extremely heavily chatting, right? Then the server's gonna send you the list of users in that channel, which basically is back to this pattern here. So the server's then number 2. So I could, for example, say this is either a server or a client in this particular case, and then basically you will then know about all the clients there is connected to the server. And of course you will also receive the client's handle in some way to identify to the server who you want to chat to. So let's assume this is the client 1, this is client 2, this is client number 3. Well, basically, and don't look at the number here as the client number 2, so I'm basically just going to delete it for now and say like this is illustrating the server we're communicating with. So if we are as number 1 here, C1, let me just put the right names to now. So let's assume we're connecting. So the first one here is connecting, so it's connecting. So alright, connecting. It's beautiful when I write with my mouse, I know. So you are connecting, and then the server is basically telling you who's connected. So who is connected. Let me get this right. There we go. And then what you do from here, it's basically up to you. It could be you sending a message, or basically anything you would like to do. So usually this is how it works, and when I say usually, it's basically because this is what you call an application layer protocol, and an application layer protocol is located on the actual application layer, which is a part of the OSI model. And if you don't know about the OSI model, I suggest you go ahead and look it up. I'm gonna create a video about it in the future about networking, but for now it's gonna be mentioned this video as something you should definitely look up. But I'm gonna have videos about the OSI model and networking and how stuff work in networks in the near future. It's gonna be within the next 3 months, I think. But I have a lot of projects at the moment, and basically it's gonna be wild. So yeah, okay. So this is basically what a client server setup is, and how the protocol is connected. Not communicating, sorry. So the protocol is a set of rules that's going to dictate how 2 parties or more parties should communicate with each other. basically that's it. So we're getting back to the TCP protocol. Basically it's the same. It's a protocol, so it dictates a way for two or more parties to communicate with each other. And the question is always, the actual communication itself doesn't necessarily mean, a lot of data being transported. So the question should always be, when you hear about a protocol, what is the purpose of the protocol? Now, if you're imagining like using something called Skype, and you have your Skype server and you have your clients connected like this, basically you can say, is there a Skype protocol? There is. What does it do is the first question. And the answer should be, well, a Skype protocol is providing users a way to communicate with other users, transfer files, images, share screens and whatever, right? Stuff like that. So that is a way for two clients to interconnect with each other through the server. They're never connecting directly with each other, so there's never gonna be a direct link like this. That is gonna be no. Let me just make it black so we can see like this, and there's gonna be a red cross. I do have a symbol for that. I do not. So it's gonna be like, no, we do not have a direct connection. The connection itself will follow the green line, so it's gonna be this up here to the server and then back. So that is the way it's gonna bounce back and forth. Basically, that is what the Skype protocol does. All right, so now we're gonna go back to the part of TCP. I'm gonna take this here and scale it down and put it right there, and then hopefully you can still look at it and say, yeah, that is what I meant when I talked about it. The TCP protocol is located on the transport layer on the OSI model. Now, the OSI model consists of 7 layers, and the second layer, well, not the second, but the fourth layer in this particular case, is going to be the transport layer. There are many different models to describe internet connections, and there's also something called TCP IP protocol stack, which is basically the OSI model cooked down to, depending on who you ask, 4 or 5 layers. Anyways, all the talk about layers should definitely not be where you should be confused, because it doesn't really matter. What really matters is that you understand the basic concept of the TCP protocol. So the TCP protocol stands for Transmission Control Protocol. I'm not going to write that with my mouse. So Transmission Control Protocol. Now, of course, this is going to be a video not too long, so I cannot go too much in depth with it, but there are different things attached to the protocol of TCP that we're going to discuss. One of them is called security, of course, and another one is called slow start principle. Did I spell that correctly? Let me just see. It's very important. I did. And yeah, we're also gonna talk about congestion control. Definitely didn't spell that correctly. Let me just do that. Congestion. There we go. It's with a G, not a J. That's the difficult thing about being non-native speaker. All right, so we're gonna talk about these topics to this particular protocol here. So I'm just gonna make it look like we have a we have a bullet point list here. There we go. So the first is, I'm going to discuss the security implications of the TCP protocol. Now, the TCP protocol itself doesn't have any, encryption protocol or functions, whatever you're going to call it. It doesn't really have. Like, most protocols are basically something you can draw like this and say you have the actual head of the protocol, and then you have the payload. So the header is like that, and then you have the payload there. That is typical how protocols are designed, and within the header, different kind of information can be located. In the TCP protocol, you're gonna find stuff like the port. So there is ports, of course, here, and other kind of things. So the ports is dictating which port you're sending and receiving data from and to. So basically, it's not that important for understanding the TCP protocol, but it's nice to know that if you're going to define a port, it's going to be within the TCP part of the protocol whenever you're using that, for example, in programming, or if you're going to modify that. I'm going to get to that in a bit part. Other interesting head informations in the TCP protocol is something called checksum. There is actually a checksum, so let me just write that. There are many other headers we could talk about, but I basically just gonna mention the ones that's gonna make most sense. Let me just put that here, and the payload is gonna be put there, so we have a beautiful setup, so it doesn't look that messy. Let me just remove that as well. All right, so this is basically gonna outline our protocol here. So what is the payload? That is all the data, whatever data we are sending. And this brings us back to the actual question: what is the TCP protocol for? What is it? What is its use case? The TCP protocol's use case is to transfer data from party A to party B. So we're gonna go back to this diagram here. So if the C1 is sending data to the server, then the TCP protocol is the transmission control carrier for the actual segment of that data. Imagine you want to send, let's say, a text file like this. Let me just write, text file. And what you're basically gonna do is, well, you're not gonna do it, but what the computer will be doing is chopping off this text file in chunks. It could be anything depending on the length, of course. I'm gonna write, this as a segment. So this one here is a segment, and basically all of the different chunks that I made is gonna be different segments. So let me just illustrate what I mean by putting on a few segments here. Let me just put the rest while I'm at it. Why not, of course. So this is all the segments there is, and then I need to put a small green line on the right. There you go. Okay, so basically this is all the segments that's gonna be, and the TCP protocol is then responsible for making sure that these individual packages of the file is being sent from C1 to the server, or who else is going to receive it. Doesn't really matter who. What matters is the actual receiver is going to take the file and then basically connect all these different kind of segments to one full connected file, or just one file, and then save it on the actual hard disk. Or if it's something that should be located in the RAM, it's going to be located in the RAM. Is it for the database, going to be the database? Depending on how you program your stuff, it's going to be used that way. But of course, there's also a chance you're not programming anything. It could be that you're just someone that's going to handle security, and you are installing software. So yeah, that's about a different kind of case, but this is the same principle. So that brings us back to the actual question: what is it the TCP protocol for? And that is for transferring data back and forth. There's a checksum, as we talked about here, and the checksum is directly connected to the data right here. So if the data is intact, the checksum can be checked and basically say the data is intact. If it's not intact, well, then the TCP protocol will try and resend the same package. So let's assume that this package didn't get received by the receiver, and it's going to be resent. Basically, that is another that's what the C part means of the control. So it is controlling the actual transmission, and basically that's going to be the most easy way for me to explain it to you. All right, so I just remove these small lines. So security. Now that we understand a few more, stuff about a few things about the TCP protocol, we're gonna get to the part of security, right? So there is no way for us to verify if let's assume that someone changes the data part here and changes the checksum. There's no way for us to know it. and not even TCP protocol provide a way to verify whether the data is changed. So if this data, for example, was a part of an image, and then I suddenly change it interconnectively, so of course, I'm doing a man-in-the-middle attack, so let me just put this pretty fast on paper. So this is the first party called C1 sending the data to the server, but then we have the evil hacker, there you go, in between, that's gonna connect to me in some way, or intercept it, right, and send it back to the server. So there's no way for me to know if the checksum and the data is being changed by that hacker. The protocol doesn't really provide, which is why the protocol itself isn't secure. If you combine it with other things, let's say HTTPS, so we're using the HTTP protocol to actually encrypt our data, then it's fine. But if we're not, we're just using the raw protocol itself, basically it is as insecure of me walking outside within, a tank shooting me down. I have no protections, like boom. So if you're good enough with security and know what you're doing, basically you can change whatever you would like to do, and there's no way for us to verify. Also, there's no way for us to verify if this guy here, the evil hacker, is eavesdropping on our packages. So there are many different problems with the TCP protocol that wasn't thought in when it was developed back in the, I think it was the 50s. I think it was laid out in the 60s, implemented, something like that. So it's very old, and we do need to combine it with other things in order for this to be secure. I'm going to talk about slow start principle. So when we are sending data back and forth to, let's assume that we have right here, C1 is sending data directly to the server, then the question is, and will always be, what is the available connection in between the two parties? So what did I just do? So we don't really know. So the best question might be now, do we just send full speed? Are we just sending with 1 gigabyte data to the server, like I'm going to send everything I can? The answer is no. So the slow start principle is basically all about that if you look at it like a scale like this is 0, and this is the amount of data, and this is time. So D for data, T for time. Then the amount of data is gonna be sent gonna slowly increase to some place where we can normalize. So the graph is gonna be like this, and it can go up and down, depending on the speed available on the cable. This is what the congestion control is all about. So the slow start principle is starting the connection with a slow speed, which is also why when you are downloading software, it's gonna start like slowly. It's not gonna start like boom, then you download with 10 gigabytes in a second. Maybe it would look like that, but that is probably because you have a really good connection and the other party connections have a really good connection. But in theory, not in theory, practical, it's gonna start slow, basically. And that's how it works, really. So I hope by this video you're gonna be a bit more informed about what is the TCP protocol, what is its use case, what is a protocol in all normality, how does the TCP protocol work, and responsibilities, and of course that it has no security and eavesdropping is a possibility, and you need to connect the TCP protocol with another protocol that is possible to or able to encrypt the TCP message, basically, and this is what we call the payload. So I hope you can use this video for something, and basically if you have any questions or need for my attention, just write a comment below. I usually respond really quick because I feel that is the best way to connect with you guys. So until next time, take care.